Okay, looks like we have both judges. You are free to start.
All right. Well, thank you for having me. My name is Jordan Clark, and today I'm here to show you how human perception AI can help Northeastern achieve its 2025 vision of quantifying learning that happens everywhere. Before I do that, first I want to thank the committee and everyone who put on this event. A lot of things have been canceling because of what's happening globally, and I really appreciate the opportunity to have an outlet to channel some of this anxiety to really help people understand that in this age of humanics, just how interconnected we are. So a little bit more about myself. I'm a double Husky and lifelong learner who is on a quest to quantify how the environment impacts me. And so for the last 2 years, I've been methodically collecting data to build a proof of concept model for what I'm about to show you today. Currently, I am also a data specialist at Affectiva, which is a pioneer in human perception AI, a subset of motion AI. And currently, I work in the AI automotive lab where we collect data. And so to help understand a little bit more about human perception AI before we dive into the presentation, I want to show you a video. So hopefully
we are on a mission to humanize technology by building artificial emotional intelligence. We realize in the automotive industry that a lot of the players are focused on the outside of the vehicle, and no one is really paying attention to the inside of the vehicle. Our technology is able to identify if you're distracted while driving based on whether your eyes and your head are on the road or off the road. Indicators of drowsiness. If you're yawning, you're feeling great, they can alert you and suggest that you maybe stop for some coffee, can adjust the music or the temperature. We are also able to identify facial and vocal expressions of emotions such as joy, anger, laughter. When we're able to detect all of these social and cognitive cues, the car can adapt in real time to increase safety, but also improve your experience as an occupant or driver.
Awesome. So that was Rana, the CEO and co-founder of the company, and really thankful for the opportunity to work there because it's really advanced this research idea that I've had. And so in order to make this a little bit more interactive, as I'm going through the 5 stages of the 5 steps of the multimodal models that I'm hoping to build at Northeastern, I want to make it interactive for the judges. So please feel free to write questions in the chat if you want, or to show your screen, raise your hand, interact somehow. It's unfortunate for virtually, we lose some of that emotional intelligence and ability to understand if somebody has a question or is thinking or is curious, which is, well, again, where Affectiva's emotion recognition technology comes in. So with that said, the first step of my poster and the research that's crucial to training human perception AI models that we could start doing right now, that, as you saw in the video, I do currently in the automotive lab, is collecting data. And so when we think about data, we think about biomarkers and so the first step is the data collection layer. And there's 3 sections of this layer. The first one is the facial detection and recognition model, and then the motion analysis and behavior analysis. Currently, Affectiva's technology that you can use and download the app and try it out is its face detection and camera recognition. And as we think about how society and technology is evolving and how Northeastern is committed to quantifying learning that happens everywhere, we need to think about how cameras associate with learners. And so in the presentation, you'll see that there's 3 learners and 4 cameras. And just taking a moment, and I want you to think about, well, what can you deduct or see or understand from it? And if anybody, again, if a judge or somebody wants to interact and share what they're seeing or what they're noticing, please feel free. Otherwise, we'll just take about 10 seconds and just think about what you see. So I empathize so much more now with my professor in my urban theory class when you ask a question and you can't tell if somebody wants to do that. So with that said, the diagram is representing, in a nutshell, 3 learners taking pictures of each other in a classroom. And I say in a classroom because Camera 4 is what I'm proposing Northeastern implement in its 2025 hub. When it wants to, again, quantify learning that happens everywhere, it's going to need to think of an Internet of Things. And with its new ISEC building happening, which I think is dedicated to the Internet of Things, this is online to what Northeastern is doing to achieve its 2025 vision. And so with cameras in the classroom, the way human perception AI works, it has to be very context specific. And so right now we're focused on the automotive industry, and we collect data in cars so that we can prove that our technology can detect emotion in a car. And in order for human perception AI to work in a classroom, it needs to be context specific. So we need to put cameras in classrooms that are measuring learners as they're learning in the traditional classroom environment. And so by having camera data, we're able to identify the association between learners and what's happening in the camera. And that is important because by cameras having the ability to detect who a learner is an object, so if there's a camera, as you can see, it would know that this is a water bottle. And as it's evolving, it will know that this is a smart water bottle, a Hydrate Spark. And so every time I drink water, it collects data and it's tracking, and also is connected to my health score, my Apple Health, and therefore it will make a goal for me based on the number of steps I take, based on and a lot of different factors that we'll get into. And so by a camera being able to know how specific this water bottle is, then it will be able to detect faces better. And ultimately, how the facial detection system works at Affectiva is 3 stages of the face detection, landmark recognition, and then facial analysis. That currently the technology is able to detect emotions such as joy from smile versus anger or disgust. It can also detect biological markers such as gender, race, or age. And so with the evolution of camera vision and more biomarkers and data, we're able to collect a more accurate picture of learners in their environment. So we can move on to the emotion analysis model and the behavior analysis model. And just quickly, as I see we're running out of time, just want to show, this is an example of gyroscope. So I said I've been collecting data to help show different ways that you can help learners learn about themselves. So this is one of their portals that allows me to go into my heart rate and understand my heart rate variability as I'm sleeping. And it also creates a health score and a data and analytics score. What's really cool about the health score is that it is in real time calculating an overall picture. It's not perfect because it doesn't have, like, say, my brain waves or the number of air particles in the room or anything like that yet. But right now, it helps me understand how my sleep affects my productivity. I'm able to look at trends. And so this is just an example of all of the data that you can collect in methodical ways to help people understand, say, how your mood affects your focus or how your overall mood affects your overall health score. And so when you think about just the impact of that data revolution that's happening right now, when you collect that data, what happens at Affectiva is in the cars, we come in, we run participants through studies, and ultimately that data we're collecting is to train models. And that goes to the second part of the motion data and annotation layer. Again, if there's any questions, please feel free to chime in. But this is the part where you have to label the data in order for it to understand what's happening in the picture and to see if it's accurate or not. And how that works is it uses Affectiva's world's largest emotion repository of 75 countries with 5.3 million faces analyzed and 2.2 billion facial frames. And so by having all of that data, the model is trained to be more accurate. And the more data that you train in, the more good data that you give into it and train it, the better it can be. And that's where we're seeing right now with the third stage of the layer, which is the data fusion and cognition layer. And so, but in order for human perception to work, it doesn't just use your face. It also has to understand gestures and body movements. And so this is an example of network analysis of deep learning for facial analysis, but think about that with adding in now your tone, your voice from a microphone, so tone analysis, speech analysis, if you have a brain cap on, your brainwave analysis, all of that data going in there to train the model to understand that when you make this face, it's connected contextually in the classroom learning environment to the learner. And then what we're also seeing right now is social media is data. When you write, every time you post something on the internet, you're creating a digital trail that can be analyzed. And so as a data scientist, I do a lot of work with sentiment analysis. And ultimately, you can take, say, your tweets and do a topic modeling and break your tweets up by topics, and then take the words of the associated with those topics and understand how positive, negative emotions associated with them. I use a lot of emojis, and there's actually a lexicon analysis for quantifying the emojis. And so when you think about how we communicate with each other and evolve, that's very personalized. But if you can get a generalized score, you can help people understand ultimately what Northeastern is doing right now with SAIL, which is self-authored integrated learning. And so I'm going to put into the chat just 2 links so that people can explore what I'm talking about in terms of the apps and also my journey. And then I'll save the last few minutes. Again, if there are any questions or anything, people feel free. But the links will bring you to what I'm using Airtable, which is a cloud database to connect my SAIL learning moments with my mood score and my overall behavioral and motion analysis, so that I can help Northeastern understand that we can start collecting data now and start training it and start labeling it in order to have models that connect with SAIL's 5 dimensions of intellectual agility, global mindset, personal and professional effectiveness, social consciousness and commitment, and well-being. But it takes a lot of work, and in order to do that for a whole system in 5 years, right now it's 2020, we should start doing it. So again, that's an overview of how human perception AI will help Northeastern achieve its 2025 vision of quantifying learning that happens everywhere. Judges, if there are any questions or anything, please feel free to ask. Otherwise, it's open to everybody. Yes.
You're around 3 minutes left.
Hi. So this is a very ambitious presentation, so I have a lot of questions I could ask. And I apologize for this since there's very limited time. I'm going to jump right to the hardest one I have. Could you say a couple words about privacy concerns with regard to this approach?
Yeah, absolutely. I'm actually reading Professor Hartswood's Blueprint privacy book right now. And ultimately, when we think about the designing this model, we have to think about privacy involved. And at Affectiva, privacy is it's in plain language. We're using your facial recognition data in a data bank, and we're not going to sell your data. We're not going to exploit it. And so, when you think about core values of Northeastern and the learners that come into Northeastern, you're giving Northeastern a lot of your data already, whether you're aware of it or not. And so, helping learners understand how to use that data will help them understand that, yeah, I guess somebody could hack me and could take my mood score and understand like how happy or angry I was, but like in the overall picture of how it would benefit me, I think people would be willing to do that, as long as it's again designed in a way where people feel like they have an opportunity to opt in to, say, having people label their own data in Northeastern's ecosystem, or paying people for their data. So there's lots of innovative models that we can use to address the privacy concerns.
Right. And if you're in, say, a classroom setting where there's multiple people, quite a few people present, is that additional concerns?
Absolutely. I think, we're building, we're one of the few, this would be one of the few data banks that's using precise emotion technology in such like a complex contextual situation. So in a car, in a cabin, just trying to make sure you have the camera angles right to detect for people in the car and who they are and the associations with them is a lot of work. But we can start building models now that by the time when technology's more advanced, Internet of Things, where it's more connected and we can get more precise data points, our models will be better than everybody else because we've already had a head start in collecting data and labeling it.
Thank you.
Thank you for your questions.
Hi, I'm Rob. I'm the other judge. I just wanted to follow up on, so is the ultimate outcome to provide individualized learning assessments for each student, or is this more of a classroom-wide, for example, assessment of student engagement during a course?
Well, so Northeastern's mission is quantifying learning that happens everywhere. So right now, like, this is a learning moment, and it's your ability to reflect and capture that. And so we're recording it, so I could run analysis to provide myself maybe feedback on how to give presentations virtually versus in person, and how I convey emotions like that. And so if somebody wants that precise data to help themselves and give them that feedback, which I think a lot of people we're seeing right now would benefit from, then we could do that. But at the same time, if that's not something you're interested in, then we wouldn't provide you that data, because people can get flooded with all of this data. Like, yeah, maybe I don't need to know my water every 2 minutes, like first steps. Like, but if you have a health concern, or if you know you need something, that data can help you understand if you're getting it or not, and if that's affecting you. So I think ultimately the same applies with learning, and everybody learns differently. So your models will need to be trained to be personalized. And the more data you give it, the more a sleep data understands, the better it understands my sleep patterns. And so if you start, and I always tell people now, like, my Bite Snap is a food journal. You take a picture and it uses machine learning to detect what it is in mixed guesses. So it's easier to log it, it's quicker. But ultimately, I have pictures that of all of my food that then, if I want to put in my mood, it's now timestamped. You can kind of do that, and that's ultimately what Airtable allows. And we're over time, but we could go on for a long time. But it's all of these data just in tables and rows that, like, as a data scientist, I love, because it's then your ability to interlink them, and that's that, like, third layer of fusion data connection. And so the hard part right now is the algorithms, and how do you build an algorithm that knows that when I drink my water at this point and I take a step over there, that, like, that should change my goal and in real time. And that's a lot of work, but I think it's possible.
Excellent.
And so again, I know we're over time, but they said that they won't kick us off. So if anybody now, I think, wants to ask questions or, share insight, please feel free. We're being recorded. Gotta let people know that.
Thank you for your presentation.
Questions, please feel free to ask.
Hi, so I'm Sarah Connell. I'm one of the focus judges. So I have one quick question, and then I am going to have to dash off. But I was just hoping you could talk a little bit more about the way that SAIL would sort of play into. So I've been really
now joining.
Oh, sorry, that was very distracting. Little notification there. I wanted to start by saying the poster itself is admirably designed, and I really was very impressed with the way you sort of moved people through the research, and especially it's effective as a digital poster. So I appreciate the fact that you thought about the switch in medium. But the thing that I couldn't quite get from the poster, and I would love to hear you talk about a little bit more, is how that final integration with SAIL would work. Like, what are you sort of imagining, like, that part of the puzzle sort of doing?
Yeah, so SAIL is ultimately, and I think I'm still sharing my screen, so I think you can share it. So this is like the SAIL platform currently. It's, again, a way to visually see just like the opportunities of learning moments. And so when you click in, you can dive and read about it. And with there it is, with Airtable, it's the same concept. I kind of ran out of time, so thank you for asking that. Where these match trees are in here, the same concept, just different emojis. But the learning moment. So I had a learning moment here. If it's on my view, then you can see you can start connecting your moments, and then there's a bunch of other tabs that I'm working on that will then have my mood scores in there, so then you can see my mood when I had this learning moment about why we need more women CEOs. And so SAIL has the framework that allows me to put my emotions in a way that connects to their learning models. And so those are the 5 dimensions, and then under them are the masteries and the skills. And so by labeling learning to, like, the hard part of emotion AI right now is how do you understand if you're learning, and how do you show a computer that? Like, as a former teacher, it's like you have to use a lot of facial cues, and you need a lot to understand if somebody actually gets it. And that's what SAIL's mission is. And so by start collecting data and labeling it, that's ultimately what I'm doing in this Airtable. If you change it again to like a Excel, that's where the connection in the SAIL comes. Is SAIL allows the framework to be very personalized to Northeastern, that will achieve, because again, Alan said in his Robot Proof book, that SAIL is the app to measure the learning that happens everywhere. And so by adding human perception AI, we can do it and achieve it by 2025.
Cool. So, and just another question. In the other direction, could it also be used for data validation to see how successful the automatic predictions are actually, like, from the perspective of the learner?
That is an awesome question. I'm glad you asked that. So last year in my Rise, I presented, during Rise, I had the opportunity to be in a hackathon, and we worked on a predictive model mock-up of something very similar, where how do you know if a university is achieving its outcomes? You know, we have certain metrics right now with graduation rates and earnings. So, you know, they're very broad. But now when we have all these data points, you can disaggregate them and validate them to ensure that the university is actually providing what it says it is. And then you can predict so if I want to work in human perception AI, what classes did I take? And that is in this model where my classes are connected to each one of those opportunities. And so then you can say, oh, well, how can I learn from other people and their learning moments in those opportunities to help me achieve it? And that ultimately is, again, like a prediction of if it works or not. So doing it in a methodical way will help computers understand how we learn.
Perfect. Well, I'm sorry I have to dash off, but thank you. This really is a fascinating project, so I really appreciated getting to learn about it.
Thank you very much for your question. Again, the questions are open. I'll stay on. Also, keep talking and go into every Excel and all of the awesome technology, but I'll be mindful of people's time. So, again, if people have any questions, comments, feedback, ideas, please feel free to share. You could school that 15 minutes other than normally you're there all day. Awesome. Thank you, Jackson. Appreciate it. Awesome. Thank you. No, hi, Dia. Hi, Alex. Okay, I'm sorry. I'm sharing. I'm still not a pro at this team. But yeah, 308. So we'll hang out for 2 more minutes. Again, if anybody has more questions, I don't know if I can have participants. Oh, I think these are all people